Okay, the idea here is that we're given the conditions for two linear equations. One of the lines has a slope of 2, and it passes through the point 1, -1. And if I was drawing a quick sketch, like I was on scratch paper and sketching that line, there it is, passing through 1, -1 with a slope of 2. And then another line that goes through 8, -5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And 10, -10. 6, 7, 8, 9, 10. And this time I'll use the line tool. The line that passes through there, those 2 points, we're trying to find that point right there, the point of intersection. So the idea is that if we could find the equations of these two lines, then we could solve that system of equations to find the point of intersection. We want to do that algebraically, obviously not by graphing. So how do you write the equations of these two lines? Well, basically you can use point slope, which is y minus y sub 1 equals slope times the quantity x minus x sub 1. So for this first equation, it would look something like this. Y minus a -1 equals the slope times x minus 1. And if I wanted to, I could get the y by itself. So this would be 2x minus 2. But then when I subtract 1 from both sides, I get y equals 2x minus 3. So that's the equation of this line right here. Now, to find the equation of the second line, I first need to find out what the slope is. So I'll say the slope of the second line is the change in y sub 1 minus y sub 2, so minus 5 minus a -10 would be -5 plus 10 over the quantity 8 minus 10, or 5 over -2, or -5/2. So now that I know the slope, I can use either of these points and point slope. So y minus a -5 equals the slope times the quantity x minus 8. And if I wanted to, I could remove the parentheses over here and get the y by itself. So I'd have y equals -5/2 x. -5/2 times -8 is positive 20. But then I have to subtract the 5. So that would be plus 15. So the equation of this red line is y equals -5/2 x plus 15. Now, all of that I would maybe perhaps do on scrap paper. If I actually share the screen here and go to Desmos graphing calculator, you can see that the answer that we're looking for is the ordered pair 4, 5. I've plotted the 3 given points, 1, -1, and a line with a slope of 2. That's this equation right here, which also could be written as y equals 2x minus 3. And I calculated the slope of the second line, change in y over change in x, and got -5/2. And that's this equation right here, which could also be written this way. And it looks like they intersect at 4, 5. The question is, how do I find that algebraically? So I'll go back to the room here, and we've got this system of equations. Y equals 2x minus 3. and y equals negative 5 half x plus 15. And probably the easiest way to solve this system is to use the substitution method. In other words, take this value for y and substitute it into the other equation. So we've got 2x minus 3 equals negative 5 halves x plus 15. Usually when I'm trying to solve an equation that contains a fraction, frequently I'll clear the equation of fractions. In this case, I'd multiply both sides of the equation by 2 because of this denominator, which means I have to multiply every term on both sides by 2. So I get 4x minus 6 equals negative 5x plus 30, and 9x equals 36, or x equals 4. And when x is 4, I can substitute into either of these equations to solve for y. If I substitute it into the first equation, 2 times 4 is 8, 8 minus 3 is 5. So it turns out, as we concluded on Desmos, I didn't get a very accurate graph here. 1, 2, 3, 4, 5. They should have intersected there. So the line should have looked like that, which is why we usually don't solve systems by the graphing method. But the point of intersection, or the solution to the system of equations, is the ordered pair.